This is the homework video for 3/20/17, and you are doing the bridge thickness problem. Give it a try on your own before you watch the video. The biggest thing is you should be able to graph this on your own, and by now you should also be able to label the numbers and variables in the equation by yourself. Okay, so it's giving us this data. I recopied it over here. Because it seems like some of you struggle a little bit with figuring out how to number the x and the y-axis. So the way to do that is just look at your numbers and look at how far apart they are, which is also called the range. So the range of the x numbers goes from 6 to 1 or 1 to 6, and so they have a range of 5. They're very, very close together, and so when numbers are close together like that, they have a small range. You should count by a small number like 1 or 1/2. On the y-axis, the biggest number is 61 and the lowest number is 12. And that's a range of 49. That's a little bit bigger, so you probably want to count by something a little bigger than 1. I wouldn't do 2s or 3s, but you could do 4s, 5s, 6s, all the way up to 10s. If you did anything bigger than 10s, you probably went a little overboard. You do want your graph to be fairly spread out, so when you count by big numbers like 20, what happens is that you're making more estimation about where you're putting your points than when you're counting by small numbers. So you don't want to go too small because that would be ridiculous, but you don't want to go too big either. So 10s is probably the outer limit of how big you should go on this one. I chose to do counting by a halves on the x-axis and by 5s on the y-axis. Notice that I'm numbering by something different than I'm counting by. So this is a half, this is 1, 1.5, 2, 2.5, 3. Because you don't need to label every single tick mark. And when you have a small space, it's actually better not to, because you can see things better. This is 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65. So I didn't number every single tick mark here. I just numbered some of the tick marks, but you can see that I'm counting by 5s. Okay, so then we place our points, and I've got those on here, and then we have to put our line of best fit. In this case, I wanted to keep the line of best fit starting at 0, 0 because the kids are doing an experiment with layers of paper and how many pennies it takes to break a bridge with that many layers. So if you have 0 layers, it's going to take 0 pennies to break. And then I just tried to put it so that, you know, it was close to the points as possible. I was only able to get 1 point really on the line. And now I had to find the equation of the line. So to do that, I put in a slope triangle, and I used my 552 and my 0, 0. And the change in y is 52. That's this. And the change in x is 5. And so if you divide y, change in y, by change in x, you get 10 and 2/5. So my equation is y equals 10 and 2/5 x plus 0. And then I have to label everything. So the y is the total pennies it takes to break. The 10 and 2/5 is as the layers increase by 1, the number of pennies to break increases by 10 and 2/5 pennies. The x is the number of layers, and the 0 is at 0 layers. It takes 0 pennies to break. You do not need to have the 0 in your equation, so if you left that out and you didn't label it, you don't need to worry about that. The secret message is how many pennies, you need to answer this question, how many pennies will it take to break let's see, let's find a number in between here. Let's go with, according to the line, how many pennies will it take to break 3.5? layers. So you would go here to 3.5 layers, and you go up to the line, and then you would go over. This is 40, but I'm a little bit below 40, and so maybe 39 or 38. So I can put in the point, whoops, at 3.5 layers, and this is the secret message. It looks like it's going to take 38 pennies to break. That's it. Have a great night, and I will see you tomorrow.